Thank you very much, Professor Schweitzer. So it's a pleasure and an honor for me to be here tonight. Welcome, everybody. My name is Kittle, and I will start off with a few slides introducing my institution. And then I will talk about augmented reality classes or smart glasses and other wearables. And to this end, I will start with my presentation. So it's about augmented reality glasses for consumer and industrial markets. So as Dr. Stubenrauch already pointed out, it's very important to always keep in mind the user. And it's not so much about technology, it's rather about how technology can assist us in creating better lives, in having more quality lives. So let me briefly introduce my institution. So what we do, we are a so-called K1 center in the COMET program. This is a Center of Excellence program of the Austrian Research Promotion Agency, which runs this program for the federal government. We are 35 full-time equivalent staff members in Graz, and we have a subsidiary in Vienna. And yeah, we have been founded back in 2000 when we started off as a center for interactive e-business. And since 2007, we have a focus on mobile technologies and applications. And we are co-owned by AVL, which is the largest privately owned combustion engine and this engineering company. And it is headquartered in Graz, about 6,000 people working for AVL, and Raiffeisen. So these are two companies that you would not immediately associate with R&D in the field of mobile business. But as you will see, these are just kind of primus inter pares. So those are those who took over the ownership of the center. But we work with many other companies and different industries. Many of those you may know, you may recognize the logo. And we also work closely with scientific partners. So we understand ourselves as kind of a bridge builder between science and industry. You can see that we also cooperate, for example, with JKU, so the Johannes Kepler University, and we have several companies from abroad as well as our partners. So these are the partners with whom we have a so-called agreement to conduct a research and development program which lasts for 4 + 4 years. And in addition to that, we do research, development, and consulting for many other companies. But enough about myself and the institution. Let's talk about augmented reality. Let's talk about wearables and what augmented reality glasses mean to our lives and why are they relevant. This is a graph that is taken from a Cisco white paper, and it shows that the internet, it evolved in waves. So the first wave was actually the fixed computing. You went to the PC and you had access to the internet there. Then the second wave, the bring your own device and mobile revolution, you always carried the internet in your pockets. All of you, I'm sure, have a smartphone and do access the internet from there. And as you can see, already back in 2013, we crossed the step to the next wave, which is currently the Internet of Things, because already now more things are connected to the internet than classic mobile devices which are used by people. And up to 2020, it is projected that up to 50 billion devices and people will have direct access to the internet. Cisco's talking about the Internet of Everything. That's also the term that is being used by Qualcomm. But I prefer the term that has been coined and used by the GSMA, which is the umbrella organization of the mobile network operators, and they speak about the connected life and connected living. And I prefer this term because it rather suggests that it's about the people, about their lives, than about the things, like the Internet of Things and everything suggests. So as you can see, 50 billion devices will be connected by 2020, and that will be devices and things and objects of our everyday life, as Dr. Stubenrauch already pointed out. So all objects of our everyday lives will finally be connected, from chairs to tables to dustbins even. And you may think, what could there be a meaning in connecting a dustbin to the internet? Well, actually, that's already taking place. For example, in Finland, many dustbins have sensors so that they can sense whether they're full or half empty. And only if they're full, then they need to be emptied. And thus you can optimize the route when emptying the dustbins. We are currently setting up a similar network in Graz. We do that with ORS, which is a daughter company of ORF, the Austrian broadcasting station, and the French broadcaster, Sigfox. They build a so-called Internet of Things infrastructure, or machine-to-machine communication infrastructure, which allows to communicate at very efficient, low power, and you don't need to equip all those objects and devices with SIM cards, which would be very expensive, but rather they need just a small device, a small receiver, and thus you will hear about that trial in the next weeks. So we are going to connect many things from dustbins to all kinds of different parking places, telling a central server whether the parking place is empty or can be used. And you will see that practically all things will be connected finally. Chairs, there will be many sensors in every object. A chair could, for example, detect whether you sit correctly in it, or you do it like I often do. Then it could detect your current temperature and say, ooh, you got high temperature. It may be time to go to the doctor. And you for sure don't want every seat to do that. So which seat will you give the permission to take control of your life, more or less? So which things shall have the permission to access your data? That will be one of the main questions in the coming years. Okay, one more slide about the future. This is a projection by Machina Research. It's already a bit outdated because the further you go, the more these projections are corrected upwards. They say that about 25 billion devices will be connected, and that the machine-to-machine devices will outnumber tablets, PCs, so classic internet access devices by 2020. And that will have an enormous impact. You can see impact on the one axis, and the industry size on the other. And as it is not very surprising that in the information services domain, there will be the highest impact. Meaning that, for example, if you can connect 50 billion devices to the internet and all of these devices will be equipped with SIM cards, that would be the holy grail for the mobile network operators, right? So they don't have only 8 billion people that they can equip with SIM cards, but rather 50 billion, or you name it, number of devices. So that could have an enormous impact in that field. But the largest sphere is on the right-hand side. It's about manufacturing. So the biggest impact, the largest impact when it comes to value at stake, is about manufacturing. And here we're talking about Industry 4.0, as has already been introduced. I have another slide on that. And that means that there will be many, many sensors. Not only, of course, in our everyday objects, it will start with production. It will start in the industry. You see many different sensors that will be available because they will be so cheap and so small that they can be practically implemented everywhere. Already now, a smartphone has 10, 11 or more sensors, ranging from accelerometers, gyrometers, and so on. So you name it. And in the future, all different objects will be equipped with sensors. And all objects will be connected. So there will be connectivity on different levels, from the personal area to the wide area networks. All things will be connected. You probably heard about pills that you can swallow and that have a small camera in it, so that you don't have to take those difficult operations where you insert something into your mouth and then it is really I like the word here, but it's hard for you to swallow that thing. Instead, you use a pill, and then you can see whatever is going on in your stomach. I have a few examples of that. So connectivity on different levels, from personal area networks to wide area networks. And finally, of course, people and processes. So there will be a huge change in many processes and business models in the future. So if, for example, as I said before, dustbins in the future will tell whether they're full or empty, that will mean that there can be route optimization. And you can think of so many different business models and processes when there are sensors measuring all kinds of usage hours, for example. For example, an elevator, you could always measure how fast are the doors closing. And if the doors are beginning to close slower, then there may be a problem arising. And before the doors get stuck, they can be serviced. So if you connect all those things to the internet and measure all those things, you of course create big data, and you have to make meaning out of this data. But in the end, it's all about how can we improve the life of the people, and that's core. And as it has already been mentioned before, the fourth industrial revolution, Industry 4.0, is actually a term that has been coined by in Germany, and it has come across to Austria, I would say, at the end of last year, when there was a first call for proposals in the so-called Produktion der Zukunft call of the Austrian Research Promotion Agency, so production of the future. And it's about these topics. The first revolution was the mechanical, the steam-based things, in the, how do they call it, water and steam-powered mechanical manufacturing. Then the second one was the electric powered mass production, and it was not the automotive industry where it was first used, as one could assume, but it was rather a slaughterhouse in Chicago that first used this technology. Then the third revolution was automatization, and now with the fourth revolution, we talk about cyber-physical systems, we talk about social machines, we talk about intelligent and smart products. And I don't want to bore you with all that stuff. I want to come to the point about the augmented reality things. So when we talk about Industry 4.0, it's really about the augmented operator. It's about the people in the center. How can we assist people in doing what they need to do in the industrial environment? So you see in the center, the augmented operator, augmented by data classes, by mobile devices, etc. And then we have the physical and the cyber-physical world. We have social machines talking to each other, just like we have social connectivity now through Facebook, through Twitter. Currently, we have very separated platforms. So you have Facebook, Twitter for person-to-person communication, and we have machine-to-machine communication platforms. In the future, that will converge, and you will get notifications, maybe from, I don't know, from your lawnmower, saying, okay, I have just finished mowing your lawn, and I return back to my garage. Maybe you don't want to hear about that, but it will be possible. And already now, for example, the Tower Bridge in London is tweeting when a ship moves beyond it or under it. So it says, okay, Queen Mary is just going through the bridge. Okay, that may not be very helpful, but in the future you will get, or we will be able to get information from many different objects, and there will be a unified platform for that. Okay, then we have also smart products. So the products will know with which machines do they need to be produced, what will be the next step. Need they be, for example, graved? Should there be a name on it? Should they be colored in a certain form? So that will all be determined by the product itself, and the product will have RFID chips on it. It will have various sensors on it saying, okay, temperature got too hot or too cold and I'm no longer usable as a product. And you have virtual production. So there will be a lot of 3D printing, for example. You probably heard about 3D printing, but it's really already coming to our lives. Barilla, you probably know the noodle manufacturer. Barilla, they will bring out a 3D printer for noodles later this year, or maybe at the beginning of next year, where you can print your noodles in any form you want. And for example, in Barcelona, there is a restaurant. All of their desserts are already printed using 3D printers, all of chocolate and all kinds of materials. So many things will be printed. I talked to one professor from the Karlsruhe area, from Paderborn, and they said 3D printing is also a great tool for copyright protection. Because things that you produce with this 3D printing, for example, for the automotive industry, they can only be reproduced with the same production facilities. And thus it's no cheaper to produce that in China than it is in Germany. So the 3D printer, the high-end 3D printer costs €500,000 in Germany, just like in China. So there is no sense in copying it. Okay, now the augmented operator, how will he or she be augmented? And if you take a look at the Gartner hype cycle, you probably know that it's a cycle saying that all technologies basically go through such a cycle of first inflated expectations, and then there is a valley of disillusion, and finally you reach a slope of enlightenment when the technology is actually used in a productive form. And you can see that in 2012, augmented reality was just over the peak. So peak means big expectations, normally too high, cannot be fulfilled. And then it goes down, and people think that will never make it to production. That will never make it in our everyday lives. What's interesting, if you compare that with the 2013 hype cycle, then you see that augmented reality moved on. It's green. It says it's still 5 to 10 years from the plateau of productivity. But what's new there, and at the very top, is wearable user interfaces. And it's not very surprising because Google Glass first came out in 2013, and some other technologies like smartwatches became popular then. So that's really at the very top now. So what do we understand under a smart glass? And when I talk about augmented reality glasses here, I really mean a head wearable device which allows users to insert digital information, but that's important, is not pure video glass. So it's not something that you put on your eyes, like could be something like this, where you don't see anything from the real environment, but you just see a digital image. That's not meant. It's augmenting what we see. And already now there is a multitude of different smart glasses available on the market, or at least announced to be launched soon, when actually it normally takes a bit longer than what they announce first. But there are quite a few smart glasses available already. And what makes up such a smart glass? First, you need some kind of display or projector, of course, that you can see the image. You need an operating system to run the device. Some storage, because you want to take pictures, you want to run any applications. You need a battery, of course. Then you need some kind of connectivity to your smartphone, because probably not everything will be in the smart glass. For example, in the Google Glass, I will present later, there is no GPS device in the Google Glass because it costs a lot of battery. It drains your battery pretty fast. So it relies on connecting the Google Glass to your smartphone through Bluetooth, and then we go from there and use GPS from the smartphone. Then we have a camera. Very often, some speaker or microphone, so that you have also audio connectivity, maybe a touch field, something like that. I will show that. It looks like a smartphone, but it's actually a touch field. Different kinds of sensors, like compass, light sensors, and maybe even external storage. And if you look a bit further, then you can differentiate the displays. You can have optical see-through or micro displays. So you could have displays like this one where you see through. It could be binocular, like here, or it could be a monocular, like this one, where you only have the display on over one eye. It's a micro display. Of course, you can have different size, resolution, just like other displays. And then the control, you have very different kinds of controlling smart glasses. You may have something like that, which you can put around your wrist in order to steer it. Also with gloves, for example, when it comes to ski goggles. You can have such a touchpad. You can use it with gestures here. You can voice control. You can even use a smartphone to control the glasses, etc. And in the future, probably also smart watches. So you don't always want to voice control your device, because if you're, for example, in the tram or in the underground, it is pretty strange to hear people say, "Okay, glass, take a picture." You would rather press a button on your smartwatch maybe, or do some other kind of gesture. And you could also have eye tracking and gaze control. So there could be another camera measuring what are you looking at, and then give you additional information to that. So many kinds of different control options. A few examples of augmented reality glasses or smart glasses which are currently on the market. Epson is one of the main producers. You may know them from the printing market. So this is the BT200. This is the latest model from Epson. It still looks pretty heavy, and it is. But it's already a big step forward from the BT100. I didn't bring that. It's even more clumsy. But you can try it later on then, after the lecture. It is binocular, and that means it's also very well suited for 3D and real augmented reality. Then Vuzix. Vuzix is another producer. We do have these glasses at our research institute, but they are very filigrane. So you always fear that something might break, or so it's very prototypical devices still. Recon, a Canadian producer, they produce, for example, the Recon Snow. Actually, here there is an inlay. It's just small, and it's an additional display. And when you're driving with your ski goggles, I will show you that later on, and you look down, then you can see, for example, how fast am I going, or how many meters have I already traveled. And another example is the Recon Jet, which is especially suitable and usable for sports. So they say they focus on, for example, cycling. that should have come out already a long time ago, but it will come out probably next year. And one of the currently best smart glasses is from Optinvent. And then there is also another one from Lumus, which is a Israeli provider. Of course, those devices come from military, and you can't get them on the market, but they cost about 7,500 to 10,000 euros, so much more expensive than, for example, the Google Glass, which is actually exactly $1,500, and which you can already now buy in UK and in the US. Yeah, and of course there could be total immersion. That's what people thought when they were talking about virtual reality, and we're not talking about virtual reality here. So you may have heard about Oculus Rift, which is actually a glass which completely isolates you from the surroundings. You just have two monitors in front of your eyes, and you can simulate a virtual reality. And Oculus does that pretty good, really pretty good. And the thing that they do so good is they are very good at tracking the movement of your head. So with very little latency, so less than 20 milliseconds. And that was always the biggest problem when doing virtual reality. No, that takes some time to show you that slide. When you move your head and the display doesn't follow immediately, then people get sick very easily. Some people more, some people less. But that's really what Oculus did very well. And that's also the reason why Facebook bought them for more than $2 billion earlier this year. Okay, so comparing a few models here, Google Glass, Epson PT, the Vuzix, Recon Chat, you can see that some do have GPS modules already in them, others don't. Some have big storage, some have small storage, and some are suitable for augmented realities, others are not. So that ski goggle is not usable for augmented reality because the display is only so small. So that doesn't make really sense to augmented reality. Yeah, as I said before, augmented vision is not augmented reality. You can have virtual reality, and in this case, we just augment the vision, but it's not really augmented reality. To say a little bit more about this device, it has a built-in micro display about this size, about 400 by 240 pixels. It has a GPS antenna, some sensors. It runs on Android OS, and that means it's pretty easy to write applications for it. And it can connect via Bluetooth or Wi-Fi to your smartphone. And there is a remote control, this one, which makes it easy to steer or control the device, because if you wear gloves, it's rather cumbersome to manipulate any small buttons, and here you have large buttons. So what we did with this is we developed in a EU project a system for Schladming 2030, which is one of the major skiing resorts. And last year we did that as a pilot project. We fixed cameras to the lifts, to the ski lifts, measuring how many people are queuing up at the lift. And that would then always be transmitted to your smart goggles. And you can always see how many people are queuing up. And you can then decide where you want to go, because there is less waiting time. So that's automatically detected. Or you can get, for example, information about the speed that you travel. You can get information about huts, what kind of menu do they offer. And that's possible because Schladming has an infrastructure where all slopes are equipped with Wi-Fi. So you have always connectivity with Wi-Fi. And we did a lot of user experience evaluation and focus groups, finding out what will people actually use and what do they want to see, what kind of functionality do they want to see. So we didn't, for example, we didn't expect them that they would like to see weather information because they just need to look up in the sky to see the weather. But it was very important for many people to get a weather forecast for the next hour or next 2 hours to say, okay, will it be snowing or not? Yeah. Also, what we implemented, and that was the hardest thing. A navigation, a turn-by-turn navigation, like you know it from the car. And it's so difficult because you don't have any streets on the slope, obviously. Everything is just white, plain white. So how do you determine when to turn left? That was quite tricky. Yeah. Also, you can have images in there, but it's all pretty small, so you have to experience that later. And when we talk about augmented reality, that's nothing new, actually. So that has been around for decades. You can see there are many different kinds of trials for augmented reality. On the right-hand side, you see an apparatus which is about 3 meters in diameter, which was meant to track head movement. So like that. You can imagine if you can only go like that, that's not very real, not really augmented reality. And that's what Oculus does so good. But it has been around for many years. And only 10 years back, you still needed an equipment like this one to do augmented reality. It looks like from the Terminator movie, really. So it was already usable for special kinds of usage, but not for everyday life. And nowadays, everyone has devices in their pockets so that they can actually do augmented reality with their smartphones. Everything you need is in there. You have a camera, you have internet connectivity to insert augmented information, processing power, you have the possibility to detect the location of the user, either by GPS or through markers that you scan with your camera. Everything there. But there is one problem. You always need one hand to hold it. So the biggest advantage, really, of data glasses and smart glasses, it is hands-free. Now, I want to give you a very brief demo of what's currently possible using augmented reality, and this is a live demo, so there will always go something wrong, probably. Now, let's see. Okay, here we go. So this is where is it? Here. This is something that we developed for AMS, which is not the Arbeitsmarkt service, but rather the Austrian Microsystems. They produce chips. And to explain their customers what these chips do, they use this augmented reality application. So you can see the board is automatically detected. So the image that the camera gets is compared with a pre-stored image, and then we can, for example, see what kind of copper layers are in this board. So it's only 2-layer, but I can see it pretty clearly. Or I could say I'm interested in the magnetic field of that board, and I can see it in 3D. Or I want to see more details from, say, a certain part of the board, and on the right upper right side I can click on schematic, and I will get information how this part of the board is actually constructed. This is one example. Another example which we did for, where is it? Sorry. Okay, here we go. Another example that we did for an engineering company. Need some time to load. We will be available soon. So they produce gearboxes, they produce powertrains, and all that's being done using CAD programs. So you can see that is a picture which is used as an anchor for this 3D object, which you can then see from all sides, right? And it's pretty high quality. And all that stuff can be rendered from CAD programs without any additional efforts, because all modern CAD programs can export a format that we can automatically insert in our augmented reality viewer. So I need to turn down that again. All right. That's a bit cumbersome still. Come on. Come on. Yeah. Now I'm stuck. Yeah. Okay. Come on. It doesn't want to switch back. Yes. Was there any question? No. So if you have any questions, feel free to come here. Here we go. Feel free to come forward anytime. Okay. So that was the other example. I just showed you some static examples, but it could also be dynamic. So those models, they can rotate, but I'm not allowed to show that. So some of these models are protected, but it doesn't have to be static. It can move. It can, for example, the cylinders can go up and down, and so on. So that's all pretty easy, actually. Another thing that we did with augmented reality for AT&S, they produced the printed boards for the iPads, for practically all smartphones. And they are also Austria's largest investor in China. And we did for them a application where visitors of AT&S, they get an iPad 2 device, unfortunately only for the duration of their stay. And there is a master iPad for the tour guide, and he or she can remote control all other iPads, so they always see what the tour guide presents. And in some places in the company, there are QR codes and augmented reality markers. So using this, the camera of the iPad, you can get additional information, videos or whatever, about the current station. And using that augmented reality marker here, we are able to calculate the angle with which the iPad is held and perspectively correctly overlay information. For example, there is a 60-meter long machine here where drilling takes place and then copper is added. And up to now, the tour guide could only say, okay, that's where drilling takes place and where copper is added. But it's much more lively if you can actually see how it's been done. And when people hold their iPad there, then you see that here the drilling takes place, and then here chemical copper is added, and that's how the printed board looks like. So here the copper is already added, and that's automatically overlaid when you hold the iPad. So the next step then, of course, is that's still cumbersome to hold the iPad all the time. Next step is to use glasses. In this case, we have, for example, experimented with Google Glass. We have been developing for that for about 1.5 years now. It was not easy to get that at that time because you had to be US citizen and it was not allowed to export it. So it was kind of a gray area that we moved in. But the main feature, as I explained before, is the hands-free feature. And whenever you think about using smart glasses or augmented reality glasses, then you have to think about, is it really important to have both hands-free? because many times or often you can do much better using a smartphone or a tablet because the screen size is bigger. It has more computing power. The battery lasts longer. Only if there is really a need for hands-free operation, then you should think about smart glasses. So one of the projects we do in that field is a so-called Production of the Future project called Assist 4.0 for assistance, a digital assistance system. We do that together with Knapp Logistics, Infineon, AVL, and some research partners. And actually, it's all about people again. It's about how can we assist people in production processes using these new technologies. It's about security, it's about social acceptance and acceptability. It's about learning. How can you use the technology to assist learning? And also, of course, how can we use resources efficiently? And the project is built on 3 pillars. The first pillar is context sensitivity. So we try to find out in what context are users using their smartphone, their glasses, in relation to objects. So objects have context, the machines have context, and you always want to present the information to the user in the right way, in the form that he or she can best make use of it. And some information is interesting for a user with one role and completely irrelevant for the other. So you need context. Then we have the front ends, many different kinds of front ends, smartphones, tablets, smartwatches, glasses. And you have the back end that needs to provide all that data that can then be displayed context sensitively. And to give you a few use cases, what we actually do there, one with the logistics company is a smart picking solution. The picker is a person that takes a piece from a warehouse and puts it on a shelf, another shelf, which is then commissioned. And up to now, people had to know very well where they find which piece in the warehouse. And with that solution, they now have a turn-per-turn navigation. They get an information showing where do they have to take the piece out, how many pieces are still in there. Then they take the piece. There is a barcode on it. They hold it in the camera. The system says, that's the right piece. Please bring it there. And this is an easy case, actually. So that's already implemented. And you can already commercially buy that case from a logistics company. And actually, Knapp Logistics, they are the most advanced in the world with this technology. So there was a report in the Washington Post about that, and Knapp Logistics, they are really far. Another example that we do is bidirectional live audio and video broadcasting to support a service technician from the back end. So very often it's too expensive to send the most experienced people anywhere in the world. And then you may have a service technician inspecting, in this case, a turbine or whatever, and get assistance from the back end. And I can show you a prototype of that in a second, or actually I can do it just now. So I will use the Google Glass to that end. And we have developed a platform which allows you to see what I see. And the Google Glass reacts on voice. So whenever you say, OK, Glass, it reacts. And I say, support me. That's the command that we defined as a trigger. OK, Glass, connect to back office. And I get now a call here. You see that? And I take that call. Okay, now I need to make that a bit smaller. Okay, so you see what I see. And I'm now both the service technician and the back-end employee. But what I can do now is I can take one of the images that's been taken from the stream, and I could say, okay, look, there is something very important. You need to look at this. And I have that here now, and I can react on this. Or I could say, I want to upload, that could be, I don't know, that could be a schematic saying, okay, take a look at that, check that out. And I say, okay, not very much, not very helpful to see the jellyfish here, but still interesting, okay? And I could then see here a recording of, and take one of the images out, and thank God it's blurred, so we don't have any privacy issues here. But I could again manipulate that, and I could record that, and for later, for documentation purposes, I could show other employees what I did, or I could, for training purposes, I could show them how to fix certain issues. Okay. That's what I just showed you. A third thing, maybe I also give a brief demo of that, is for the maintenance and service use case. So you see here, there is a machine and there is a two-dimensional barcode on it. That's being used to identify the machine. So the camera of my smart glass will identify the machine using that 2D code. I have it here, so normally that would be on the machine. And if I now, and that's not the tricky part, because you want to see what I see, but I cannot at the same time run the service application that I used before. So what I now have to do is, I connect the Google Glass to, where is it now? Here. To an Android device. So you could already now see what I see, but it's very small. So what I will now do is I will use another device. Yeah, I know. It doesn't look very promising, but I hope it will work. So you see, it's still very prototypical, yeah? Okay, and I use the camera here. No, I'll take the other one, sorry. This one. Okay. And now you should see what I see. Okay, and you do. Okay. So there is some delay because the Google Glass now transmits the image via Bluetooth to the first tablet. I then take a picture of that with the camera, connect it with Wi-Fi to, you see, not very promising, but it seems to work. So, okay, I'm not trying to show you once again this back office thing. And one of the problems with that thing is that it takes quite some time to synchronize. So that's the home screen of Google Glass. And now I have set Glass, and it recognizes Glass, and it now asks me, okay, it thinks I have, I tried to take a note. I don't want to take a note now. Okay, I'll have to, okay. Okay, what I want to really show you is this. This is a demonstrator where I would now scan this QR code. I don't know if you could see that now. Yes, now you can. Okay, and now I would get in 16 steps an introduction, how to maintain, how to service the machine. So first I get some warnings that it's a laser class 4 device which I'm trying to service. It says turn off the device before you open the measuring chamber. Some additional warnings which I all confirm with a swipe. And then finally it says, okay, wait sufficiently long for the measuring cell to cool down, and I confirm with a tap. That's practically the okay. So if I tap the glass. And it says step 1, switch off the device. And then it shows me how this is done. So I get a 3D animated, okay, in this case it's not very helpful because that's easy. But then for the other steps, step 2 is still very easy. Okay, opening the housing lid. Remove the screws. Okay. Remove the measuring chamber cover. Okay, I repeat it. And then, and so on. So now you can imagine if I get that step by step, and I could also use voice control, say back, forth. I can get good information for how to service that device. Now again, that's the tricky part. Come on. For some reason, it doesn't accept the gesture. Now, okay. Okay, back. So this is what I just showed you. I want to also present you some guidelines. So if you want to develop for smart glasses or augmented reality glasses, what do you have to take care of? That's taken from the Google design guidelines. First, design for the glass. And you may have many different devices. You may have data stored in the cloud, which should be there forever or not. You have data on your PC, on your smartphone, probably pictures, videos from last month. And what you do with your smart glass, because it doesn't have a lot of storage, and normally it's meant to record what's going on right now and immediately sends it to your Google Plus account, in the case of Google Glass. So this is a device which is meant for right now. And it's also important that you design it so that applications don't get in your way. You should support the user and not take the life of the user away. So one good example, again with the jellyfish, is if you look in the aquarium at some jellyfish and you may want to get additional information, you could, for example, get that information at the wink of an eye. So Google Glass can detect when you blink with your eye, and you could say, okay, when I do like that, give me some information about what I just see. Also important, keep it relevant. Don't clutter the user with information that is not relevant in the context that they are in. So, for example, in this case, it may be very relevant to get a shopping list, a predefined shopping list, or a list of items that seem to be missing in your refrigerator. But you probably don't want to get any, I don't know, football results in this case. And also important, avoid the unexpected. So don't always send the user any information which they do not expect at that point of time. For example, don't send any advertisements in the middle of the night when the user is maybe somewhere in a bar or sleeping, right? And finally, build for people. So, for example, the messaging of Google Glass, it prioritizes people's faces, and you can speak naturally, more or less, and then when you're done, it will automatically be sent. So you can use, for example, the Google Glass and connect it to your smartphone, and then you can take calls using Google Glass. You don't have to take out the smartphone anymore. You can get directions. So you say, OK, class, get directions to Vienna, and it will show you the way. So that's really helpful. But then again, it's not allowed to use it when driving still. but that may change. Some more developer policies. There's a long list, of course, but that's just a selection. Some of these policies say no ads in the glassware, not even based on data which you gathered from using glass. No face or voice recognition for other people than the user. It's easy to recognize faces. You probably know this Fraunhofer application. If you have a camera, a webcam, and I would point it in here, it would not only detect all your faces, it would also show me which is the percentage of happy people. So are you 70% happy, 10% sleepy, and so on. And that's working pretty well. Not 100%, but pretty well. And you could, of course, also do that with smart glasses, but Google says you're not allowed to do that. Then the display must be kept active while recording videos, so that you can see from the outside also that it's recording video. And if you are now say, okay, class, record a video, it will only do that for 10 seconds. And people around would be aware that a video is recorded. And then if you develop glassware, which are apps for Google Glass, you can put it on the glassware store, but you may not charge any fees. Okay. A few things about the interface. So the main user interface is that of a timeline. If you swipe to the front like this, then you can go back and forth in time, saying on the right-hand side, you see what just happened. You took a photo, Herald Tribune pushed some news to your Google Glasses, and you can go back a few seconds, a few minutes, half an hour, whatever. In the home screen, that's what's happening right now. That's also why the time is displayed. So it says, okay, class, it's now 7:05 p.m. And if you go further to the left, then you go into the future. You see how will the weather be tomorrow, which places could I visit nearby. So it shows you some places suggested to visit, etc. And you can use the OK class voice command to start applications. You can say, OK class, play a game. And we'll ask you, OK, play tennis or something like that. And there are several applications running. And you can use those gestures, or I forgot to translate, to the front, back, down, and tap, which are basically swiping and canceling and the OK tap. Basically, there are two kinds of applications that you can run on your Google Glass. One is a HTML5 content, which is directly inserted in this timeline. You can insert any HTML5 content. And the other is a native native glass application, glassware. And you can develop that using the Glass Development Kit, the GDK, which is an extension for the normal SDK from Google. Well, the normal card-based functionality is, for example, used by the Washington Post, the New York Times. They can send you updates. And you can even say, OK, class, read aloud, and it will read the news to you. It has a bone conductor. So the Google Glass has the battery here and also a bone conductor. It lies on your ear bone, and you hear the voice through the bone conductor. There is no plug or so. And it works really amazingly well. Okay, some more design patterns also. So you start an application, a glassware, from the OK Glass command. Then you run the service. You can have a static card inserted in your time frame to access the service later on again. You insert some live cards. You can tap to activate any menu items, and you can stop it and remove the live card then. But you have to experience that later on by yourself to get a better understanding of how it works. So when we talk about user experience of smart glasses, there are several factors affecting that. One is, of course, display quality. People, when they first put on the Google Glass, normally they think, wow, that's a small picture. I thought it would be much bigger, the image. It's only like this size. And people expect that it is filling the whole view angle. It's not. Google designed it the way that it doesn't always overlay the image that you see, and that you have to deliberately activate it. You can activate Google Glass by nodding your head or by using voice control, and then it's slightly above the eye line. So you have to look up like this to get the information. This is meant to allow people to still look each other in the eyes. So there shouldn't be this display always between them. A big issue still is battery lifetime. The Google Glass lasts for about 2 hours, and less if you do a lot of video and stuff, computing stuff. But it's also not meant to be used for 2 hours. You go crazy pretty fast when you do that. It's meant as a support item, which you can use throughout the day to get direction, to get some information. For a few seconds, you look up and say, okay, I know this guy, give me some more information or so. That's how you can actually use it. Otherwise, you will always be out of battery. Form factor. This one is really heavy. You don't want to carry that for more than, probably you don't want to carry it at all, but it's really heavy, not for a long time. Personalization. The Google Glass is available, for example, in many different colors. That may be an issue. Privacy and security. Everything that you, every picture that you take with the Google Glass is immediately sent to Google Plus account. And if you're not careful, it's immediately shared with many people. Social acceptance. You may have heard that, especially in the US, there is already the term glass hole for people wearing Google glasses. And there are restaurants having signs where there's an eye in the Google Glass and it's crossed and say, no Google Glass in here, because people don't want to be disturbed or recorded. And finally, of course, the price. Some further wearables, and I take a look at the time. Do I have a few more minutes? This is a forecast showing what kind of wearables will dominate the market in the next years. You can see that smart glasses, the dark blue, there was practically none available in 2013, and it's coming up strong. The same for the smartwatches. Pretty strong, but the biggest number will be the sports and healthcare devices. So measuring how many steps you took, measuring your blood pressure, and I have a few examples about that. What also will be important is gesture control. As I pointed out before, it's very difficult if you're in the tram to always say, okay, class, you don't want to do that. You also don't want to do that all the time because people may think you're crazy. But what you want to do is probably make some small gestures. And there is a device from Thalmic Labs called Myo. It measures the contraction of your muscles. And if you make only small gestures like with your fingers, you can already steer then a smart glass, for example, or any other device. We ordered that, I don't know, a year ago when it was first presented on Kickstarter, and they promised to send it in the next few weeks. So hopefully we'll get that. But it's from the videos you can see it's working amazingly well. So you just make small gestures, and it allows you to interact with devices. Another example of how to combine data classes with other wearables. Fujitsu presented this one at the Mobile World Congress in 2014, so in Barcelona earlier this year, where the worker is wearing a data goggle, and then he has a smart glove with a NFC tag reader. NFC, NFC is near-field communication. It's a short-range communication technology, so 4 to maximum 10 centimeters. And using that, you can identify, for example, a certain cable. And the smart glass application would then show you where to put that cable. So combining different wearables will be very powerful in the future. Other wearables. Google is, of course, trying to leverage its power in the operating systems market that it has on the smartphone market for other devices, especially for the smartwatches, because you saw that surging, but also for cars. I'm not going into that here now, but you probably have heard about the Google car. Google says in 5 years they think they will be ready to launch it on the market, and it has been traveling without drivers in Nevada for more than 2 years now, and they say it's more secure than any human driver. But here in this case we use it for smart watches, and the same, of course, has been presented recently by Apple. You probably, or you may have seen the presentation of the iPhone 6 and also the Apple Watch. And what's special about the Apple Watch? 2 things, actually. I don't think that you will use many applications on your smartwatch. Doesn't make a lot of sense because the display is so small. But 2 things why I think Apple brought that. One is the sensors. You see here on the back side, there are a few sensors measuring, I don't know, blood pressure and frequency and so on. And it assists your sports and health activities. So that's also the reason why Apple often presents the Apple Watch with this image. That's an image showing your personal trainer. It shows what you have achieved already this week. So if the circle is full, then you have achieved your full goal, and otherwise you see what's still to do. So they're tapping into this sports and healthcare movement. And the second thing is the Google Watch is also equipped with near-field communication, and you may have heard about Apple Pay. That's a mobile payment system, so that in the future, or actually already now in the US, you use your iPhone and you don't need a credit card anymore, but you just hover your mobile phone over the POS device and it will behave like a credit card. And this is only possible with the iPhone 6 now. And in order to make it also possible to use that with all the iPhones, so with the iPhone 5, 5C, 5S, you can use the smartwatch, which is coupled through Bluetooth with your iPhone, and then you just use your smartwatch to pay. I think these are the 2 reasons why Apple developed that, and the healthcare topic is very important. And Google, in turn, did similar things. They presented earlier this year a smart lens, which a small Wi-Fi chip and a small sensor measuring the glucose level. So for diabetics, they don't have to measure the blood glucose level anymore and pin themselves, but rather it's measured through the tears. And they partnered with Novartis, and the Joe Jimenez from Novartis said that he would be disappointed if they cannot bring it to the market within 5 years. And similarly, of course, augmented reality moves on in a similar direction. So in the future, you will no longer have glasses, you will have smart lenses. Prototypes do already exist. University of Washington presented some, and one company also has already prototypes available. They use energy harvesting, so they don't need, of course, any battery. Would be not very comfortable. And they use tiny Wi-Fi connectivity devices to connect to your mobile phone, and then you could display augmented information using smart lenses. Will take some more time, but in about 5 to 7, 8 years, I would say that will be on the market. Okay, that's all for now. Thank you for your attention, and I'm happy to take any questions.